Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll be looking at checkpoint 6.5 from section 6.2. It says to use a series that the function is equal to 1 over 1 minus x on the absolute value of x less than 1 to construct a series for 1 over 1 minus x times x minus 2 and then determine the interval of convergence. So we basically want us to, well, I think we're going to need to use partial fractions to split up this big fraction into two smaller fractions that would kind of mimic what's happening with this series or this this function, which by the way is a geometric series, right? So just as a little side note here, this series, or maybe I should just say that this 1 over 1 minus x is equal to the series x to the n and goes from 0 to infinity. And so we'll use this series to kind of make a new series for this bigger fraction. So that means we're going to need to use partial fraction decomposition so that we can figure out how we can break this up into two smaller fractions. So we have 1 over 1 minus x times x minus 2. That's going to equal to 1 over 1 minus x. Well, not 1, but some constant a, and then another constant b times x minus 2. And I think, let's see, if we remember how to do partial fraction decomposition, that would get us, if we multiply by the common denominator, that will give us 1 on the left hand side, and then we have a times x minus 2 plus b times 1 minus x. Okay, I think at this point we can use some sort of method where we can try to solve for a and b. Given this information here, let's let b disappear first. Let's let x equal to 1. Sorry, x equals to 1. Then we have the equation 1. That's always going to be 1 is equal to, and this is going to be a, and then 1 minus 2 plus b times 1 minus 1, which is the whole reason why we're doing this. And then we're going to get a is equal to, this is going to be negative a, so a is going to equal negative 1. Let's box that up so we don't lose it. And then let's also let x equal to 2 now to get rid of this a, and what we will get there is the left hand side, which is 1, is equal to a times, this is going to be 2 minus 2, and that's the whole reason why we make that disappear. And then b is going to be 1 minus 2, and that's going to give us a negative b. So b will equal to negative 1 as well. All right. So now our fraction, our function, 1 over 1 minus x times x minus 2 is actually equal to negative 1 over 1 minus x plus b is also negative 1, and then x minus 2. Okay. All right, now we want to find how we can make this into a series that looks like this thing. And well, the first one will just be a negative 1 constant that's sticking out. But I think we're going to need to do a little bit more work for the second one. So this is going to be negative 1 times 1 over 1 minus x. Now let's, on the side here, let's figure out how to rewrite negative 1 over x minus 2. Let's put the negative up here. All right. I think if we take this negative and multiply it down in the bottom and make that positive 1, this can change to 2 minus x. We can switch the order. And then let's, we did this trick before in another checkpoint where we multiply this by 1/2 and then multiply the denominator by 1/2. And then we end up getting a 1/2. This 1/2 can go all the way to the front, and the denominator will be 1 minus x over 2. So now if we just let x equal to x minus 2, then we can use that as our 1 over 1 minus x series. So this will be a plus 1/2, and then our new function that we're going to change into a series is going to be 1 divided by 1 minus x over 2. Okay. All right. Now from here we get the series. This series will just remain the same, and let's not forget the -1 in front. And then we have the series as n goes from 0 to infinity of x to the nth power. All right. Now the second one, we'll get the 1/2 sitting out in front, and then now this is a series as n goes from 0 to infinity of, now this is going to be our new x, kind of like our x for a geometric series, or our r, whatever you want to call it, the ratio. This is going to be x over 2 to the nth power. Okay. All right. So this is a series that we're about to combine. Just so we know, this is going to be the interval of convergence here. Interval of convergence. Maybe I'll do this in a different color. Interval is going to be -1 to 1 for this first one. And then the interval for the second one, let's not spend too much time on this, but it's essentially x over 2 is less than 1. And so if we multiply this, this is going to be absolute value of x is less than 2. And the endpoints aren't going to work out either, so this is going to be from -2 to 2. Now between these two intervals, if we take a look at that, we have -1 to 1, and then the bigger interval is -2 to 2. Now we know that the series converges here for the smaller one and diverges everywhere else. And for the second one, we know the series will converge here and then diverges everywhere else. So we basically want to make sure we pick the interval where everything converges. And it looks like that interval will be this interval here. And so what we'll do in this case is that I'll say, okay, this is too big of an interval. We'll use this for the interval that will converge. So basically, essentially choosing the smaller interval. Choose the smaller interval. So that's the interval of convergence. And I guess we should put this all into one series so that we can kind of summarize everything together. So let's see how that will work by putting it into one series. This is a constant that you can bring inside. So this is going to be the sum as n goes from 0 to infinity of -1. It's not raised to the nth power. That's just -1. X to the nth power here. And then let's bring this 1/2 inside. So this is going to be n goes from 0 to infinity of 1/2. And then you have x over 2 raised to the nth power. I could combine this into one series. And it would be nice if I actually had an x to the n and x to the n together. So in doing so, I will break this apart. I'll take this 2 to the n power and merge it with this 2, and then I have this -1 here. So how is that going to look like? That will look like The series as n goes from 0 to infinity of -1. Let's keep this x to the n here first, plus, and then here is the move that I was talking about where we merge 2 to the n, and then there's another 2, and so that's going to be that part. And then now they both have x to the n that I can factor out, and so I will have the series as n goes from 0 to infinity of -1 plus 1 over 2 to the n plus 1 power. All this is a coefficient to x to the n. And so this will be your series. All right, so we got our series. We got our interval of convergence. And I think that's it. We're all good. Hope that helps. Good luck.